Now let's basically relearn what we learned in the previous episode but in a different format. These are the different identification reagents and the organic compounds that they can identify. If a certain compound decolorizes bromine CCl4, it could either be an alkene, an alkyne, a phenol, or an aniline. If something decolorizes acidic permanganate or even basic permanganate, decolorized permanganate in general, it could either be an alkene, an alkyne, a phenol, primary secondary alcohols, aldehydes, or formic acid. If if something reacts with nitrous acid to produce nitrogen gas, it could either be an aniline, a primary amine, urea, or amide. So apologies for you if you can't see it. And if we were to add tolerance reagent to something, and which is ammonical silver nitrate, and it produces a white color precipitate, then what you have is a terminal alkyne. If a red-brown precipitate is produced after adding ammonical copper chloride, Cu2Cl2 actually, apologies, then we get a tertiary alkyne. That is a test for a tertiary alkyne. We know how that is a test for a terminal alkyne. This is another great way of identifying a terminal alkyne other than Tollens reagent. Now, if we were to add Brady's reagent 2,4-dinitrophenylhydrazine, and we observe the formation of a red-orange color precipitate, that is your indication that a carbonyl compound is present, and those carbonyl compounds could either be an aldehyde or a ketone. If we were to add sodium hydroxide and a large amount of heat is produced, that means what you have is an acid halide. You see here, this reaction, it happens under one reagent. We add sodium hydroxide to here and the full process goes, and it's very exothermic. Now, what if we were to add Lucas reagent, zinc chloride conc HCl, and we observe a quick turbidity? That, my friend, is an indicator of a tertiary alcohol. What if we add sodium and observe hydrogen is produced? That, my friend, is an indicator of a terminal alkyne, an alcohol, phenol, or carboxylic acid. If it reacts, what does it mean if we find a compound which reacts with sodium hydroxide does not produce that big temperature change, but basically what it means, it produces blue litmus, it makes blue litmus into red litmus, then the compound you have is either a phenol or a carboxylic acid. What does it mean if a carbonate or a bicarbonate ion solution is added and carbon dioxide is evolved? So basically it means what you have is either carboxylic acid or specific types of nitrophenols, which I will get into in a later video. Imagine we add neutral ferric chloride and a purple color solution is produced. Then it could either be a phenol or a carboxylic acid. But we can differentiate by the two by simply adding dilute acid and shaking it. If the purple color disappears, it's a phenol. If it stays, it's a carboxylic acid. Now what if we were to add nitrous acid and we obtain a yellow oily substance? Well, a yellow oily liquid. Then what we have in essence is a secondary amine. If we add nitrous acid and get a clear solution, what we have is a tertiary amine. If we were to add silver or lead ions into the solution and it precipitates as their halides. Basically, what it means is we add silver and lead ions, and it precipitates as silver chloride, silver bromide, lead iodide, blah blah blah. Basically, what it means is, and it's either an acid halide, a tertiary alkyl halide, a a halobenzene, or a diazonium salt. No, sorry, or what do you call this thing? Yeah, yeah, you, yeah, yeah. I won't do pranks again. Yeah, I'm sorry. This, my friend, is a diazonium salt. If we were to take a diazonium salt and we were to add, and it forms an azodie after we add a certain compound, that compound is either a phenol or beta naphthol. And that concludes the summary of the organic reagents. Yeah, yeah, I was joking. Okay, this is a diazonium salt. All right, a diazonium salt reacts with silver and lead to form the lead and silver halides.